Algebra Unit 3, Linear Functions, Equations, and Inequalities, Module 7, Linear Equations and Inequalities, Lesson 3, Linear Inequalities in two variables. Alright guys, so here it goes. Our essential question for the day is, how do you write and graph linear inequality in two variables? Okay, so when you do linear inequality, guys, right here, it requires us to do a couple of things. Number one, shade half planes. So what that basically means is that we're going to be drawing a line through the XY axes, and that divides that plane into two, right? And because it's an inequality, we'll shade one of them. And when we divide the two half planes, the line is going to be either solid or dashed, or it could be dotted lines. Okie dokie. Alright, guys. So when we have that, we will have something that's less than equal to, greater than equal to, right? So that right there, if you remember, that is less than equal to will be what? At most. And when it's greater than equal to, it means at least. That's the common terms that we use, right? And the linear inequality in two variables can be written in one of the following forms, guys. The big difference between there are four of them. The first, the second, the third, and the fourth. And the big difference is, if you didn't figure it out already, is that this one is less than equal to, greater than equal to, sorry, and greater than. And A, B, C here are constants, and A and B cannot be both B0. Okay, if it is, it's no longer a linear equation, right? And solution to the inequality in the two variables is one or more ordered pairs that makes the inequality become true. Well, that's like a way of saying, right here, that we're going to shade a half plane. That's requires us shading a half plane. And what we have here is this: whenever you have less, so if you want to draw a solid line, it's less than equal to or greater than equal to. If you want to have a dash or dotted line, it is less than or greater than. Okie dokie. And we'll talk about which side we graph in a second. Let's do an example, shall we? In this particular example, some students at music recital perform 3-minute pieces, and some perform 5-minute pieces. Okay. It's almost like having like quarter and a dime, right? Each coin is worth either quarter is 25 cents, dime is worth 10 cents, right? Here, we got different pieces of recitals, and some of them are 3 minutes worth, some of them are worth 5 minutes worth, right? At the total time, it's like kind of like saying you got $3, right? The total amount of time you have has to be at least 30 minutes long. So when I see that right there, at least 30 minutes long right there, I think to myself, the sum has to be greater than or equal to 30 right here. Okie dokie. All right. So the inequality represents is this. Okay, let's think about that for a second. So I'm thinking that 3x is the amount of time, right? Right here. That's the total time by 3-minute piece recitals, 3-minute pieces, right? 5y is the total time by 5-minute pieces. Did that make sense, guys? I'm sorry for the horrible handwriting, but you should be listening as you write this down. 5-minute pieces. I'm not going to write everything down, otherwise we'll take the entire page, right? It's a bit of a shorthand, right? So 3x plus 5y is the total time, the recital time by adding the 3-minute and 5-minute recital pieces, right? Yeah. So that's what that basically means, right? Okay. All right. It says solve for inequality for y. That's a fancy way of saying isolate the y variable. That's basically what they're telling you to do. So let's write down the equation. 3x plus 5y is equal to, sorry, my bad, greater than or equal to 30. Let's zoom that in. All right. So we need to get rid of anything that is not y. And let's get rid of 3x to the other side. Minus 3x plus 30. And now what do we do, guys? Yeah, exactly. We divide by 5, like this, right? You don't have to write that down, guys. You should just think it, okay? At this level. So this y is greater than or equal to negative 3/5 x plus 6, okay? So right there, that's a slope. And right there, that's the y-intercept. So this is a slope-intercept form, isn't it? Right, because we're given a slope and a point. So we could graph this thing nice and easy, right? So now, the part B, what this is saying, when you did this, guys, right? It said, replace the inequality symbol in the inequality with equal sign. The inequality is now equation that will be used to graph a line. The line is called the boundary line, okay? So what we can do is just simply copy this over, right, over here. And then instead of having the inequality, you just replace any of the inequality signs. It could be greater than equal to, less than equal to, any for them, simply with equal sign. And that thing now is called the boundary line. Okie doke. All right, let's just keep that in mind. You know what? Let's draw it first, shall we? Let's draw the boundary line first. So, y-intercept is 6. So let's count. 1, 2, 3, 4, 5. That's 6 right there. Right? And my slope is negative 3/5 or 3 over negative 5. Right? So I could go either down 1, 2, 3, 1, 2, 3, 4, 5 to the right. I will do the same except 1, 2, 3, 1, 2, 3, 4. It's around here. I have to guess, right? The other way is to actually go up 3 and left 5. Let's do that. So we go 1, 2, 3, 1, 2, 3, 4, 5. See all that, guys? I'm going to take that and go straight across. And that looks good, okay? Let me shift it up a little bit over here, guys, okay? So because the bottom right part is already outside of the grid, so I'm just going to color it over like that. So this right here is the boundary line. Now the question is, is it solid line or is it dotted line, right? So let's look at part C. Graph the boundary line in the graph below. Draw a solid line if, do you remember what we did earlier? If you said greater than or equal to or less than or equal to, you are correct. You could draw a dotted or dashed line if it's greater than or less than. So which one do we have? Let's take a look. We have greater than or equal to. Because we have greater than or equal to right here, right? We are going to draw a solid line, which I already did, right? Okay, so that's good. Now let's focus on part D, which is to say, the part of the coordinate plane containing the solution to the set of the inequality, which may include the line, is called half plane. Well, we'll include that solid line as part of the solution if it's greater than or equal to or less than or equal to. If it's dotted, it means let's exclude it from the answer. All right, so after graphing the boundary line, in our case, we use y equals mx plus b, or you could use the intercept approach, right? There are a couple of different ways in which you could do to shade. So this is what I do. Okay. Method 1. Let's zoom that in. Method 1. Oopsie. Method 1 of shading. Oops. Sorry. If you have greater than equal to or greater than, we shade above. If it's less than equal to or less than, we shade below. What I mean by that, right? I don't have a ruler, so it's hard for me to do anything here, but let me just see if I could do this real quick. Let me quickly create a ruler for you guys. How about this? There you go. So I'm creating myself a straight edge. There you go. Let me group this shape together. There you go. So one thing I could do is put the ruler, straight edge, right next to this, right? Over here, just like that. And then because we have y is greater than or equal to, well, what we're going to do is just grab the straight edge and move up because it's greater than. See that? It's great. If it goes up, where does it shade? It shades above, right? Right. It's a bit of a gimmick. I don't think you really need to have this at all. So what you could simply do is just say, hey, hold on a second. If I'm going to shade, could I just shade above this way? Yeah, that's what I would do. Just put a little arrow, and then you'll shade the rest like this. And there you go. That's it. However, in order to do this, we need to have the equation in the following form. Let me just move this out of the way. I have a bit of an advantage is that I could move it around a bit. For this method, you really want to have it in terms of slope-intercept form. Solve for y. Because we're saying y is greater than or equal to, or y is less than or equal to, or less than, it has to be in that expression. Otherwise it gets a little tricky. Okay. Now there's a second method, and that's a toe dipping approach. I don't know what to call it, so method 2, let's put it over here, guys. 2 of shading. And I actually prefer doing this. We simply test a point. Any point. And any point on the either side of the boundary line. And I like to choose the easiest point possible. And the easiest point is what? 0, 0. If 0, 0 happens to be on a boundary line, I'll choose 1, 0 or 0, 1, right? Let's think about this for a second. Let's pretend that we didn't shade yet, like this. I'm going to plug in 0, 0. If it satisfies the equation, 0, 0 is right here, right? If it satisfies the equation, it means the whole thing needs to be shaded, right? If I plug in 0, 0 and it doesn't work, it means that we have to shade the other side. Is that making sense? Let's try that, shall we? The equation, I'm just going to bring the original equation right here, guys. I'm just going to copy that equation. Okay. Put it right here. And instead of the x, instead of the x, we have to substitute 0 because that's x and that is y, right? And the y is 0. Question is that true? 3 times 0 is a 0. 5 times 0 is a 0. When you add 2 zeros, you end up with 0. Question is 0 greater than 30? Yes or no? This is false. So that means that 0, 0 is not the solution. It's on the wrong side. So what is the opposite side of that? It's here, right? So that would be my answer. Okay. So I plug it in. It didn't work. So it has to be the other side. So if it's false, shade other side. Okie dokie. If it works, we shade where the same shade the side that contains the test point over here. And that's how I would do it. Okie doke. Do me a huge favor, guys. Okay? Why don't you guys go ahead, pause the video, try these two problems. Okay? We're back. Okay. Let's do it. I'm going to do a little bit quicker, if you don't mind. So here we're going to solve for y again. First, step number 1. Isolate y. So that is when you do that, move the 21 to the other side. Negative 3y less than 9x minus 21. We're going to divide by negative 3, which gives me negative 3x plus 7. But as you know, as soon as we divide by negative, we need to flip it right away. Boom, right there. Okay? Remember, flip inequality, right? If you multiply or divide by a negative. Okie dokie. All right. Now, given this, I know that my slope, my y-intercept is what? 7, right? So you count 1, 2, 3, 4, 5, 6, 7 right there. And my slope is negative 1/3. The first thing you should know is what? Sorry, b is 7. My slope is negative 3, or negative 3 over 1, or 3 over negative 1. First of all, it's negative, which means when you're going from left to right, it must be going down. Because it's 3, it must be fairly steep, right? So that it says we go down 3, 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, one more. 1, 2, 3, right 1. I'm going to connect them, but here's the thing. It's greater than or equal to. Is it solid or dotted? It's dotted, right? So what I'm going to do is I'm going to connect them so that all I do is just put dashed lines in the middle between those little dots. And right there. Okay? So there you go. Now, I could see that this is the boundary line over here. Y is greater than, so I must shade above. See that right there? Yeah, that's it. But what you can do is just test the point. What we could do is the following. The easiest thing, okay, check a point. Once again, easiest point is 0, 0, right? Does that work? Question mark. So I like to go back to the original equation always when I do that. That's 21 minus 3 times 0 less than 9 times 0. That's a question mark, right? So that's a 0, that's a 0. So question is 21 less than 0 ever? Not at all. It's a contradiction. It's not true. When you have two errors going through each other, it means it is a contradiction. It's not true. That's not it. So we must shade the other side. So here we go. Oopsie. There you go. There you go. That's how you do it. We're good? All right, guys. Let's look at part B. All right, let's do it again. The first step is what? Isolate y. So that's 2y is less than negative x plus 14. We're going to divide by 2 to everywhere, like this, right? If you do that, we have y is less than negative 1/2 x plus 7. Once again, my y-intercept is 7. My slope is negative 1 over 2 or 1 over negative 2. Okay. 7. Let's count 7. 1, 2, 3, 4, 5, 6, 7. Okay. I don't like where I put it. There you go. That's a little bit better. Now, first thing is that it's negative, so it must be going down. But because it's half, it's probably not quite as steep, right? But we need to count. We go down 1, 1, 2. Go down 1, 1, 2. Down 1, 1, 2. Down 1, 1, 2. Up 1, left 2. Up 1, left 2. And there you go. Now, once again, that's the boundary line. So question is that a solid line or is it dashed line? Because it's less than, there's no equal to sign, right? We're going to put a dash between those bunch of circles. There you go. A little bit of an arrow at the end. So now do we shade above or below? Well, because y is less than, we're going to put our pencil where the line is. We're going to go straight down, right? So that's where we're going to shade. Is that right? Absolutely. We know that, right? But let's still check a point anyways. Check a point. 0, 0. When I plug it in, I always prefer to put the original equation. Negative 14 plus twice a 0 minus a 0. That's negative 14. That's a 0. That's a 0. It's less than 0. Is that true? Is negative 14 less than a 0? Yes, it is. Which means we're testing this point right here, guys, right? It means that that's the side that is true. So we have to shade the whole thing. So we're going to shade. Okay, let me go a little bit closer. There you go. And there you go. We're done. Yay. Okay, guys. Enough of that. There's some practice for you guys. Here we go. This is your turn. Pause the video. Okay. Let's see if you did it correctly. This is the answer. Okay. Alright, guys. That's enough. I shall see you in the next video. Have a good night and don't do anything I wouldn't do. Okay. Keep on studying. Bye-bye.